Hi everybody, it's Mrs. Dinkelman, and we're in Unit 10 where we're looking at whether series converge or diverge, and this is just two different tests that we have the option to use, the nth term test and the alternating series test. So the nth term test we can kind of use with any series of any form. The problem is it only really can give us one result. So basically if we take the limit and the limit of that is not 0, then we can say the series diverges. What this is really saying is that that very last term is not 0. So our terms are not getting smaller. They're probably getting bigger, or they're the same thing over and over, or something similar. Because even imagine if we had 1 plus 1 plus 1 plus 1, and we did that infinitely, our series would diverge. So we really need our terms to be getting smaller to be guaranteed, not guaranteed, to hopefully see if something would converge. So again, let me recap. This one says if those terms are not getting close to 0, they're getting close to something else, we're going to say it diverges. So in this note here, and that's very confusing because this was actually the test we used for sequences. In sequences, we were wondering what the last term was doing and whether the last term was finite or infinite. But at this one, it's saying if the limit is 0, we can't say for sure that this converges. We can only say it might converge still. We just have to pick a different test. So again, leave yourself a note that this one only tests for divergence. It can never test for convergence. So we're literally just looking at limits of that formula there. So I'm going to write this one as 1 minus 1 over e to the n because that makes more sense to my brain. So this is going to basically be bottom heavy or 0, so we get 1. Since we got something that was not 0, it's a guaranteed diverge. This one, if we take the limit as n approaches infinity, we get 0. So in this case, our test is inconclusive, trying to use the nth term test, that is. However, we actually know this one from last section. This is a p-series, and if the p-value is a 1, we actually know that it diverges. So I just wanted to put that one in there to show you that just because the limit is 0 doesn't mean we get to say converge. So sometimes this test can be pretty easy if we remember to do it, but again, it only works if we can prove that it diverges. And then the alternating series. So this one is a fairly easy one to see that it alternates signs. So you'll see like a -1 to the n, although sometimes they'll sneak like a sine or cosine in there to show alternating. But generally you're going to see a -1 to the n or like an n plus 1 or something like that. So if we have an alternating series and we are guaranteed that the successive terms are getting smaller, so that's what part A is saying there, that the next term is always smaller than the previous term. And if the limit is 0, okay, so we're going to be checking the limit that it's 0. If that's the case, then we can say that this series converges. So in this case, it does work to say that the limit is 0 and converges, but only if it's alternating. That's the only time we get to do that. So we're going to take the limit of the non-alternating part, and basically for us, the question is that 0? And yes, it's bottom heavy. It definitely is 0. So we get to say that this one converges. Okay, so go ahead and try those next few homework problems using just the nth term test and the alternating series test. We will, by the way, eventually get to when you just have a bunch of series trying to decide what test to use. For now, just use the ones that are kind of the headings in the section.